Welcome to today's virtual Lunch and Learn session. Today we are talking about electronic overload migration. It's Rachel Green. I'm the Digital Communications Specialist here at McNaughton-McKay Electric Company. And presenting for us today is Austin Davidson, Automation Support Engineer out of our Norcross, Georgia location. Accompanying him today is Lacey Diedrich, Industrial Controls Product Manager, also out of Norcross, Georgia. Lacey will address your questions in the comment section as we go along, and we'll also have a Q&A portion at the end for her and Austin to answer your questions in more depth. We'll be getting started shortly, but we like to allow a few minutes for attendees to join us. As you come in, let us know where you're joining us from in the comment section. As we continue to socially distance, we're happy to be able to host these live sessions here on YouTube, making it possible for you to be able to join us from the comfort and safety of your own homes and offices. You can view recordings of previous virtual Lunch and Learns on our YouTube channel under the virtual Lunch and Learn playlist, and we'll be continuing this series every Wednesday at noon, so be sure to join us in the future. For anyone just coming in, welcome to our virtual Lunch and Learn electronic overload migration. Let us know where you're joining us from. We'll be looking for your questions as you have them in the comment section while Austin Davidson and Lacey Diedrich discuss the next generation of Rockwell Automation's electronic overload relays and the benefits and migration strategies of deploying them. Lacey will also be responding to your questions in the comment section, and we will have a Q&A segment at the end to address some of those questions in more depth and to allow some time for any follow-up questions you might have. If you'd like to reach out afterwards, or if you have further questions for Austin or Lacey, you can send us an email at macandmaclive@macandmac.com. Just be sure to let us know which session you attended, and we'll direct your questions to them. We'll have that email address on the screen at the end for you as well. All right, it looks like we have a few viewers here now. So Austin, I will pass it over to you.
Hey, Rachel, thanks. So yeah, today we're going to be discussing the electronic overload migration for Rockwell Automation's overload line. So it will be, like Rachel said, myself, and I will be accompanied by Lacey Diedrich. She'll be jumping in as needed and helping me field questions. So first thing we wanted to discuss is essentially why use an overload. Most people probably already understand this pretty well, but just want to make sure everybody has a good basis. So this is your typical power circuit for a motor. So of course we have circuit breaker that's going to protect your actual circuit, the wiring in it. But at the end, we need something to make sure that the motor is protected as well. So typically we will use an overload relay for that. So essentially what you will be checking for is if too much heat is occurring on the line, and that is usually at least what was used in the past as the means of protecting the motor and checking if something was occurring that you did not expect. So why is this important? Well, as you can see on the right, we have a motor that something occurred, whether it was maybe a phase loss, just an overheating, a jam situation, but something happened to this motor that essentially ruined it. So, of course, that's why we employ the overload relays, because they are a much cheaper and a much easier thing to replace if something were to occur than your entire motor. So we have the traditional bimetallic version, which, if you're not familiar with, is just essentially an overload that has a portion that is made of two different metals that have different heat properties. So as it heats up, as the current in the line goes up, essentially they will separate and open, causing the circuit to open, and electricity can no longer pass to the motor. The only issue with this is if the heat occurs over a very slow time, or you just are not able to detect it fast enough, the motor could still fail. So where bimetallic is still used in a lot of situations, essentially we're going to address why electronic overloads are important and all the key features you get with them. So on this slide, you'll see essentially we can detect phase loss a lot quicker. So if in a three-phase situation, if one of your lines goes out, it's going to cause issues electrically. We can now detect that. We can also get information on how much thermal capacity we're using. So at what level of heat are we actually seeing, and what percentage of our full load amps are we actually seeing as well. So we can get more diagnostics with the electronic overloads. And then what's really nice too is instead of having to select a bimetallic overload that is rated for maybe a specific amperage, we actually have adjustable trip classes as well. So not only do we have more insights that we can get over the bimetallic overloads, but we also are able to make some adjustments on the fly. So this is what we're calling the legacy lineup of Rockwell's overload relays. So we're going to be discussing, this is what we previously had, what we have in the future or now, and how do we get there. So from the left to right, essentially you go from the most basic to the most premium or the higher performance on the right. So this is what we're going to navigate to by the end of the slides, just so you're aware. So our E100, 200, and 300 overloads, that's what we're going to essentially be migrating to. So I just wanted to make sure you had an understanding of where we're going on the journey. So we will start first with the E1 Plus. So the E1 Plus, why do we need to migrate? Well, the short end of it is essentially it is being discontinued. Unfortunately, the microprocessors that are used within the product, Rockwell Automation is no longer able to get from their suppliers anymore. So it was introduced over 18 years ago, so it's not any surprise that something like this would happen after almost 2 decades. So that is essentially why the migration has been forced. So Rockwell, knowing this, has set up an easy migration strategy and has basically deployed a brand new line of basic tier overload relays that have all sorts of bells and whistles and are going to give you some extra benefits anyway, just from having to migrate. So currently we're in what we call a last time buy situation. So the discontinuation date, as you can see at the bottom, is April of 2021. Now, just heed that date a little bit, because if it sells out prior, then there's nothing else we can do. So if you do need to stock these, be aware that this is the discontinuation date, but that doesn't mean that it's going to be available until then. So now that we've talked about why you need to, we can discuss how you actually do it. The nice part about this migration is this is about as simple as it gets. Almost every single situation where you are currently using an E1 Plus, the E100 is a drop-in replacement. So as you can see, I pulled out just a few pieces of a table at the top where you can see, okay, on the left is your discontinued E1 Plus. Then you can see the recommended replacement given whatever that full load amperage range is that you were using, and selecting which type of contact you're mounting to. So of course they have the IEC, which you see on the left, which is our 100C contactor, or we also, of course, have direct mounting available for the NEMA style, which you'll see on the right with the Bulletin 500 line. So the only caveat for this really is if CTs are used, then there will be some engineering that will have to be involved just with rewiring and everything like that. So we take a step back, we understand why we need to migrate, how we do it. It's pretty simple, and voila, we get the E100. So now we're going to go into essentially what the E100 gains you over, say, the 193T or a standard bimetal overload. So just a quick overview of features. This is kind of the quickest way to just show what you get real fast. Essentially, we are able to now detect, or we are able to protect against phase loss, ground faults, and jam situations, as well as we're able to get information on full load amperage and the current thermal capacity that's being used. So this is a side-by-side on the right of essentially 2 starters, an IEC starter and a NEMA style starter. If you're familiar with the IEC style of Rockwell starters, then you may notice that this looks a little bit different from the traditional starter you're used to. And that's because on the very top, the circuit breaker, that's the brand new line that has just come out, the 140M. And then as you move down, we now have this extra gadget we can put on top of the contactor. We'll get into that in a minute. And then on the bottom, you see the E100. I just wanted to give you a side-by-side so you have an idea of what they're going to look like. It's pretty similar. All the form factors are essentially the same. So what you get over a traditional bimetallic is essentially your phase loss protection and your current measurement as well. So you get increased accuracy and repeatability because you have more information. So instead of just hoping that the bimetal opens when it gets hot enough, we are now able to address it potentially before the event even occurs. It also boasts a rugged construction, and what's really very nice about these is they're self-powered. So there's no external power that you have to bring to it, no contacts or anything like that we got to put on the side. And then, of course, since it's an electronic overload, we do have an adjustment range we can make for the FLAs, and they've expanded these in the newest line. And then we also have a couple different callouts here. So on the right, you'll see essentially we have a basic and an advanced, version of the overload. So that's just an image of each. I know that it looks essentially the same. The main thing to call out is that little top left connection that we see. That is going to be essentially how we're going to communicate with the E100. So another bonus that we have now is we have a way to communicate directly with the overload, something that we didn't have previously, unless you were using maybe like an Ethernet sidecar. So here we can see that we have the ability to do single or three phase with a single catalog number. And of course, like I previously mentioned, they both have adjustable trip classes. And then we will get into how we actually do the ground fault and jam protection. Just know that those are optional add-ons that we will utilize that advanced E100 to do. And then on the right, also you see basically all the certifications that the product line has. So here shows us essentially the basic versus the advanced just in a feature set. So with external CTs, we can go all the way up to 800 amps if you need, just with the E100. We can also set for an automatic reset type with the advanced if we need. And then the jam protection and ground protection, as you see with the protection accessory, we're good to go. So we'll show that on the next slide, I believe. So this is essentially just a smorgasbord of all the different accessories that we have for the E100 line. What I'd like to call out specifically is on the right, those ERD and protect modules that you see called out. I've shown how they're mounted on the right. So we can either do that mounting directly to the face of the contactor, or if for whatever reason we can't do that, maybe you don't have the panel depth to do it, or we're not using that exact style of contactor, we can actually DIN rail mount this as well. So that's how you're going to get your jam and ground fault protection. We also have a lot of the usual accessories that you might need, whether it's a reset adapter or a panel facing indication or remote reset device, as well as a panel adapter if we're not direct mounting to a contactor. So this is essentially showing what we have currently with the E100 already being launched. We do have the majority of the product line already available. So whatever made up about 70 or 80% of what was being used of the E1 Plus, of course, that's what they concentrated on first with the E100. So the rest of the portfolio will be filled out eventually in the future, but just know that we do have essentially everything launched that you would need to make this transition. So on the left, you'll have your traditional style 100C and Bulletin 500 contactors with the overload. Going into the future, again, if you're familiar with the 100C product line, that looks a little different, the contactor we have there. So just so you know, that is going to be the 100E. That is going to be the future offering of the IEC contactors that Rockwell will provide. So as we come back to the migration, I just want to take a quick pause. Lacey, do you have anything that you would like to interject?
I think you did a great job, Austin. The only thing I would add in what maybe you're going to see as we continue the presentation is just how scalable the Rockwell electronic overload portfolio is, whether it be within like the E100 family itself, and the ability to get the accessories if you want to monitor more than just what is basically on the overload. And then within the entire portfolio, as you compare the E100 up through the E300, just the amount of different diagnostics you can pull and everything. I think scalability is the name of the game when it comes to this new Rockwell overload line.
Perfect. Thank you. So now we will, as she alluded to, we'll continue on with the line. So the next portion that we're going to discuss is going to be the E3 Plus. So here we've called out a non-networked version, and then an Ethernet and a device net version. So essentially in the past, you would use the same E3 Plus, but if you needed communications, then you would add this sidecar that we see on the top right. So E3 Plus to E300, why should you do that? Well, because it's already been discontinued. So if you were unaware, no longer can we get the E3 Pluses. So the E300 is a migration that pretty much we're forced into already. So it's the same situation as with the E1 Plus. Essentially, Rockwell was no longer able to get pieces of the part from their manufacturers. So essentially what we've had to do is we've had to revamp the product line and put out something new. Fortunately, just like with the E100, they took this time to really beef up how scalable everything could be and add in so many bells and whistles that you didn't even know you needed. So how do we do it? So there's two ways. We can either take a step down and move to the E100 overload relay, or what is more suggested is we step over to the E300, and functionally, of course, they're going to be different. The E300 is what I would consider more of a drop-in replacement. It has essentially all the bells and whistles that the E3 Plus did, and then some. With the E100, of course, you're going to be losing some of the diagnostic information that you maybe were accustomed to with the E3 Plus. So just wanted to let you know that there's two options, but by far the recommended option would be the E300 migration. So we have, again, our E3 Plus, the non-networked and the networked, and it becomes the E200 and the E300. So we'll go through why they have the E200 and the E300, why those are different here in just a bit. But just know, essentially, they're going to be the same. The E200 is just a non-networked version. So in terms of what they're able to protect against, it's going to be completely the same. And then the diagnostic features that we're going to get, voltage, power, energy, all of that will be the same. The difference is just whether we can connect to our Logix platform or not, and then feed all that information directly to a PLC. So I thought this was very interesting. So on the right, you'll see that essentially 70% of issues that cause motor failure are not overcurrent. So overcurrent is, for the most part, what we're looking for with a traditional bimetallic. Overcurrent happens, heat occurs, bimetallic opens. That still leaves about 70% of motor failure issues unaddressed. So how do we resolve this? Well, we resolve it essentially by using something as smart as the E300. We have intelligent motor control, and what that means is essentially we're using either Ethernet IP or device net to take the information and send it back to our PLC so that we're able to monitor it. We also have a scalable solution. So as Lacey alluded to, everything from the E100 up to the E300, we have something where we can find the right fit for the current application. And then all this diagnostic information that we're taking, of course, since we have the Ethernet IP, if you're using that, we can essentially take this and push it to our PLC. You can also use it locally if we're using just the E200. But I think really where you get the most power is when you take that information and then you're sending it out. So we are able to do not only control and configuration at the same time, but also data acquisition. So how do we build an E300? So most products, at least in we'll say the E3 line, we basically would buy a specific piece, and that would be your E3. So with the E300, think of it almost like a starter. You got 3 pieces to it, but in this case, we have a communication module, a control module, and a sensing module. So we select one of each of those, and that's basically you're going to have your sensing module, of course, is what's in line with the electricity, and then the control module is what has all your bells and whistles, and then your comm module is how we program it and how you access the information. So here from left to right, we have our E200 and then our E300 with Ethernet is in the middle. And on the right, we have our E300 with DeviceNet. So they all look exactly the same form factor. It's just difference in communication protocol and difference of basically that top portion. So we move over to here and we see, okay, the E200, since it doesn't have communications built into it, how do we actually program it? Well, there are dip switches that we can use on the front and rotary dials, but we also can connect through the USB port. And then if you're familiar with Connected Components Workbench, we can actually go in through that and make all of our adjustments. So again, this is going to be the cheapest version of this line, and this is going to be the non-networked kind of standalone option. If you need communications, we have, of course, Ethernet and DeviceNet. The nice thing about the Ethernet is there's 2 ports on there, so we can pretty much do any type of topology you would need. And it also has an embedded web server that we'll show in just a second, and add-on profiles that we can use via Logix. And then with DeviceNet on the right, we have basically everything you'd expect with the DeviceNet communication. The node address is set via rotary dials, and then really where this is being, I believe, targeted or made available is in the situation where you have an E3 or an E3 Plus that is on DeviceNet. This gives you an option to migrate without having to just completely move to Ethernet right away. And this shows that there is an emulation mode, and we'll discuss that towards the end as well. Also, if you need some additional I/O, a lot of overload relays are already going to be networked. So this might not be something that traditionally is going to come up, but if you do need essentially digital or analog, we have those that we can pair side by side. And then if you need extra power as the bus expands, we do have a power supply for that. And then the operator station, we're able to directly connect that as well. So if you want to do some programming from maybe the front of the panel or remotely, we can use that. And one of the nice things with that is we can use the copycat tool. So essentially, you can do all your parameter backup and restore just in case something were to happen to your overload and say you didn't have it backed up on the PLC. So this is basically calling out all the features of our Ethernet version. So again, we have essentially any topology you would want. Since it has the dual Ethernet ports, we can do star, linear, or ring. We also have this embedded web server you can see in the bottom right. Essentially lets you go in and you can go through, change all of the parameters. You can monitor everything this way. Say if you were just to be doing it remotely or you didn't have access to the Studio 5000 program that it was written in, this is a way that we can still get to it. We can also support web messaging. So say we go in here and we set up an alarm for an overcurrent or an overvoltage or whatever we want to monitor specifically for this application, we can also have that push a email to us so we know what's going on without us having to go back and actually check it. And then finally, again, the copycat tool is nice with the with the touchpad, but we also have automatic device configuration with this version because it is tied to the PLC. If you're not familiar with what that term is, I believe it was first done with our PowerFlex drives, and now you're seeing with IO Link, we're able to do it with sensors as well. But essentially what automatic device configuration is we store all the information about, say, overload A, B, or C in our PLC. So if anything happens to it, we can remove it, drop in a brand new product, and everything, all the information, all your parameters, everything that you spent all this time to rigorously do and tune, you don't have to keep a spreadsheet of that or anything. Essentially, it will download it straight to the device and you're good to go. We also have pre-configured faceplates. So if you don't want to have to design your own, this is something that's pretty standard with anything that's connected to Logix. So these are, of course, are available on the PCDC or the download center that Rockwell has. So you can see here we have anything from device status and event details to some current IO feedback and trending of, I think in this case, they're doing just full load amps. And thermal capacity being used. So basically any of our tags we can take and push straight to these faceplates that are already pre-configured. And then what I discussed earlier with the device net option. So to ease the transition, if you are currently using an E3 or an E3 Plus on device net, essentially the quick and dirty of what we can do is we can go in and we can drop in an E300 hardware, but we can, with a click of a button, we can set it to emulate what an E3 Plus would look like. So really what that means is we're consolidating extra parameters that the E3 wouldn't have, that the E300 does. And so you're only seeing your E3 Plus. And so all your communications over device net, we don't have to redo those for the time being. When you are ready to migrate over, or you're able to actually transition to the E300 and you want to take advantage of some of those extra parameters, all we have to do is essentially turn off emulation. So very simple, on, off, and it'll consolidate your parameters. So of course the device net communication is going to be easier. And I kind of wanted to just close with this. So really the main thing with, I would say across the board, almost every device we look at now on the manufacturing floor, whether it's anything from sensors to our overloads, our drives, essentially what we want more and more of is information. Because what does information do? It gives us the ability to be proactive rather than reactive. So the conventional approach would be essentially something happens, you go check on why it happened. Maybe you have some good tribal knowledge of what happens in this plant. You know that on June 7th every year, there's some kind of fluctuation in power, whatever it may be. You just happen to know that. Well, as we get further and further down the line, that just isn't feasible. And it also doesn't do you any help when you have to still diagnose what happened. So the approach that we're taking going into the future is essentially take all this information that we have available to us via either an E100, 200, or 300, and then we can make a change before something happens, before that motor burns out, because everybody knows how expensive those can be. So that's the A to B on why you would want to use an electronic overload over a traditional bimetallic, as well as how we're going to migrate from our legacy product line to the new product line that has all these great new bells and whistles for you. Lacey, do you have anything to add?
I'll just put a bow on what you just were talking about with the knowledge that you gain from using an electronic overload relay. And I personally don't know if you're allowed to do a Rockwell product presentation at this point and not use the phrase connected enterprise, but this is it. This is the connected enterprise. This is an example of the ability to put traditionally non-networked devices onto your network. Like Austin was saying, pull that preventative data, pull those diagnostics so that you can do proactive maintenance versus your reactive maintenance. And that's kind of the dream at this point in life when you're running a plant, is to not be putting out fires, but preventing the fires. And so we hope that this information today has really helped kind of clarify that. But really, if you take it back to the beginning of the presentation, you think about the traditional bimetallic overload. This is how it was done for forever. And now the industrial Internet of Things and the IIoT and everything, this is where we're moving forward. So please take advantage of this technology as an opportunity to help yourselves and to help uptime and to prevent downtime. And that's pretty much it. Austin, you did a great job.
Okay. So what about Q&A? Do we have any questions to go over?
We do not have any live questions in the chat at this time, but we'd like to give just a few moments to see if anyone has any follow-up questions. So I want to thank you both for the presentation and the information that you presented. It's very helpful, very useful information, hoping our customers take advantage of it. While we wait, I'd like to remind you that you can always reach out to us at the email address you see there on the screen, macandmaclive@macandmac.com. Just let us know which session you attended so that we can direct your question to the presenter and they will respond to you directly with an answer. All right, let's check and see if we have any follow-up. We do not. Again, I want to thank everyone for attending today. It's wonderful having you here live with us on YouTube. Remember to subscribe to our McNaughton-McKay YouTube channel for more industry content. And we look forward to seeing you live again soon on another Lunch and Learn. Thanks, everyone. Have a great day.